Okay. Welcome back. This is our lecture 3 on kinematics, and we have a new equation. X equals x naught plus v naught t plus 1/2 at squared. You notice our lettering is the same as it was in the first two equations. Our units still haven't changed, except, so to speak, you can have the naught where we have a beginning distance and a beginning velocity. In this one, you notice there is no second velocity as in the lecture 2, and there is also acceleration. So our equation for today is x equals x naught plus v naught t plus 1/2 at squared as we put in our first blank. So let's read our problem. We notice here's our v. Accelerates at a rate, so that must be a, since that's meters per second squared, for 3.5 seconds. You notice there's no x naught, so we're going to assume that is 0. Got to start somewhere. So the v, 2.5 times 3.5 plus 1/2, that's 0.5, excuse my writing, that's a 0.5, and 3.5 squared. Do not forget this. A lot of students will forget the square up here to down here. So x, knowing our units, is going to be in meters. You should be able to calculate that with no difficulty. Let's look at our second problem. We have a v, a t, and an x. Okay, so this is our today's equation. And there it is right here. And it says a distance. So we've traveled 130 meters equals 0, since there's no beginning distance, plus 23 times 3.5 plus 1/2, and now we're looking for the a, 3.5 squared. And there's our one letter left, and a, as we looked up here at the top, will be in meters per second squared. Here's another one. We're at the 1,000 meter mark, so there's an x. She had, now look at that, she had accelerated at a rate, so there's her a for 7.5 seconds to increase her velocity of 3.5 meters per second. So it says at what point? So that's x, but that's our x naught. So we have everything we need. And we're writing down our equation, since this is what we're doing today. And the runner was at that. And see, we're looking for the x naught. And she had her in 3.5 times 7.5, and then there's 1/2 times the a, and then 7.5 squared. So x naught units is in meters. Let's do a couple of more. Okay, the car has traveled this much. There's our time. Accelerate at a rate It says, what is our initial velocity? In other words, what was the velocity of it when it started? We're writing down our equation. So it traveled 500 meters, and since we were given none, I had to start somewhere, V naught, and we went 56 seconds plus 1/2, 5.4 times 56 squared. And you can see we don't forget that square. And then you have V naught is in meters per second. Knowing your units helps out a lot, especially in physics. Okay, here's our V, meters per second. Now you notice we're decreasing, have a negative acceleration. There's our time, and we wanted to know how far did it travel. So you can see x equals x naught plus v naught t plus 1/2 at squared. We want to know how far did it travel. That's going to be 0 since we weren't given that. We're going to assume that much. It's going at 32, and it went for 10 seconds plus 1/2. Don't forget that little negative, that can make a difference. And that's 10, and don't forget that square, and x is in meters. I've done 5 for you. There are some more on this page for you to work. If you have any questions, feel free to contact me.